Welcome to the session 7 of module 1. Course objectives are this course will enable students to understand various sources of IoT and M2M communication protocols, describe cloud computing and design principles of IoT, become aware of MQTT clients, MQTT server and its programming, understand the architecture and design principles of WSNs, enrich the knowledge about MAC and routing protocols in WSNs. Outcomes are, at the end of the course, students will be able to describe the OSI model for the IoT MTM systems, understand the architecture and design principles for IoT, learn the programming for IoT applications, identify the communication protocols which best suits the WSN. In this session, we are going to discuss about data management and consolidation gateway functions, constrained environment, for connected devices, COAP, the protocol, constrained application protocol. Data management and consolidation gateway functions. In this we will discuss about transcoding, integration, compaction and fusion. First is transcoding. Transcoding means data adaptation, conversion and change of protocol, format or code using software. The gateway renders the web response and the messages in formats and representations required and acceptable at an IoT device. Similarly, the IoT device requests are adapted, converted and changed into required formats acceptable at the server by the transcoding software. For example, use of transcoding enables the message request characters to be in ASCII format at the device and in Unicode at the server. It also enables the use of XML format database at the device. While the server has a DB2, Oracle or any other database. Transcoding involves formats data and code conversion from one end to another when the multimedia data is transferred from a server to the mobile TV, internet TV, VoIP, phone or smartphone as the client devices. Transcoding applications also involve filtering, compression or decompression. A transcoding proxy can execute itself on the client system or the application server. A transcoding proxy has conversion, computational and analyzing capabilities, while a gateway has conversion and computational capabilities only. Privacy, that to particular data privacy. Data such as patient medical data for supplying goods in a company from and to different locations, and the changes in inventories may need privacy and protection from conscious or unconscious transfer to untrustworthy destinations using the internet. Privacy is an aspect of data management and must be remembered while designing an application. The design should ensure privacy by ensuring that the data at the receiving end is considered anonymous from an individual or company. The components of the privacy models are devices and applications, identity management, authentication, authorization, trust, and reputation. A suitable encryption of identification of data source enforces privacy. Device ID management provides for privacy. The analyzed decrypted data is an input to application, service, or process. IoT or M2M data have to be for the beneficiary individual person or company only. When data is transferred from one point to another, it should be ensured that the stakeholder in future may not misuse the device and data or the application data. These static and dynamic relationships are components which depend on trust and reputation. A data security sublayer for confidentiality and authorization. We can use a standard algorithm, AES, advanced encryption algorithm based on symmetric 128-bit block data encryption. The access to data needs to be secure. The design ensures the authentication of the request for data and authorization for accessing a response service. It may also include auditing of requests and accesses of the responses for accountability in future. End-to-end security is another aspect, while it implies using a security protocol at each layer, physical, logical link and transport layers during communication at both ends in a networking. CCM mode, it is countered with CBC MAC. CBC stands for cryptographic block cipher with a block length of 128 bits. CCM is method which provisions for the authenticated encryption algorithm for confidentiality and authentication. Next comes the data gathering. IoT or M2M applications involve actions such as data gathering, that is acquisition, validation, storage, processing, and retention and analysis. Data gathering refers to data acquisition from the devices network. We have four modes of gathering data. One is the polling and event-based gathering, scheduled interval, continuous monitoring. Polling refers to the data sought from a device by addressing the device. For example, waste container filling information in a waste management system. Event-based gathering refers to the data sought from the device on an event. For example, when the device reaches near an access point or a card reaches near the card reader, or an initial data exchange for the setup of peer-to-peer or master-slave connection of a BT device using NFC. Scheduled interval refers to the data sought from a device at select intervals. For example, data for ambient light conditions in the internet of street lights. Continuous monitoring refers to the data sought from a device continuously. For example, data for traffic presence in a particular street, ambient light condition in the internet of street lights. Data enrichment refers to adding value, security, and usability of the data. Next is data dissemination. It consisting of three steps: aggregation, compaction, and fusion. Aggregation refers to the process of joining together present and previously received data frames after removing the redundant or duplicate data. Compaction means making information short without changing the meaning or context. For example, transmitting only the incremental data so that the information sent is short. Fusion means formatting the information received in parts through various data frames and several types of data. Removing redundancy in the received data and presenting the formatted information created from the information parts. Data fusion is used in cases when the individual records are not required and are not retrievable later. Constrained environment for connected devices. Here the data is limited in size, tens of bytes from a device, limited compared to data interchange of thousands of bytes between web clients and web servers when using HTTP, TCP and IP. Data routes over the low power and lossy network. Devices may sleep most of the time in low power environment, and they will awake when required, when a client initiates. So the connectivity breaks for long periods, have limited up intervals in lossy environment. So we data of the connected devices routes over the web in two types of communication environments. The environments are core and unconstrained environments. So the first is a constrained RESTful environment, that is core. IoT devices are M2M devices communicate between themselves in a local area network. A device typically sends or receives tens of bytes. The data gathered after enriching and consolidating from a number of devices consists of hundreds of bytes. Gateway in the communication framework enables the data of network devices that communicate over the internet using the REST software architecture. Devices have the constraint in the sense that their data is limited in size compared to when data interchange between web clients and web servers takes place using HTTP, TCP and IP. Another constraint is data routing. When routing over a network are low power and lossy, roll network is a wireless network with low power transceivers. Another constraint is that the device may sleep most of the time in low power environment and awakens when an event occurs or when it is required. Devices connectivity may also break for long periods, have limited up intervals in loss environment and have limited data size. The gathered data from number of devices consists of hundreds of bytes after enriching and consolidating at gateway. Communication framework enables the data of network device communicate over the internet using the REST software architecture. So we have the figure for IoT or M2M devices, local network connectivity and web connectivity in constrained and unconstrained RESTful HTTP environments using communication protocol. So assume that there are I devices, device 1, 2, 3, 4, like I devices. Connected, these devices connected device network and local network having connectivity between the devices at physical or data link and adaptation layer. Communication between web objects, IETF core specifications which include COAP and UDP, web objects protocols for sending a request or response, transport layer protocols used for datagram transport layer security and UDP. Hundreds of bytes communicate between the IoT web objects. Web objects, HTTP client and HTTP server communication over the internet using the IP and client or server use the URLs. And thousands of bytes communicate between HTTP web objects using certain protocols for sending a request or response. So this IoT or MTM area, local network and gateway COPE, and this is the protocols we are going to use, and communication whether through the Zigbee or Bluetooth or COPE clients, servers are there, and we are going to use the UDPs and TCPs. This for thousands of bytes of data transmission, and we can use the HTTP clients. Tens and hundreds of bytes communication framework, constant RESTful environment. And for this communication, Bluetooth, Zigbee, wireless array technologies that will be used to connect to the devices. So here the layers of physical or data link layer. So this comes under adaptation and network, transport, application support, and application layers. An IETF recommended protocol for constrained environment devices, COPE, is a web objects data transfer standard protocol for sending a request or response, for example, RESTful COPE. Object or resource uses COPE. COPE client at a device, IoT or MTM area local network or gateway sends request to a server. COPE server sends the responses, messages, resources, and notification. Next is direct and indirect accesses of COPE client objects to a COPE server, that is this figure, and COPE client access for lookup of object or resource using a resource directory, and that consisting of these blocks, and COPE client and server access using proxies, that consisting of these blocks. So here we are going to use the proxies, clients, HTTP, COPE, directories, servers, several objects, and IoT devices, and direct access, indirect access. Okay. COPE client and server access using proxies. Transport layer security, earlier known as secure socket layers, is the protocol used for securing the TCP based internet data interchanges. DTLS is the TLS for datagram. If we consider the features of DTLS provisions for three types of security services. Those are integrity, authentication, and confidentiality. The DTLS protocol derives from TLS protocol and binds UDP for secure datagram transport. DTLS is well suited for securing applications, for example, tunneling applications that used in virtual private network, applications that tend to run out of file descriptors or socket buffers, or applications which are delay sensitive. Part of DTLS is OpenSSL repository, OpenSSL 0.9.8 security based on PSK, RPK, and certificate. So the features: standard organization, IETF defined application support layer protocol, COPE web objects communication using request response interaction models, specialized web transfer protocol used for core using role network for use of object model for resources, and each object can have single or multiple instances. Each resource can have single or multiple instances, and supports resource directory and resource discovery functions. The resource identifiers use the URLs. Small message header of 4 bytes. Core communication is asynchronous communication over the role. Integrates easily with the web using the COPE application cross protocol proxies, because HTTP and COPE both share the REST model. So next is COPE MQ. So this COPE MQ is a message queue protocol using broker and RD. Roles of COPE endpoints have roles as a client and servers. A message queue protocol is a broker and resource directory. COPE endpoints role as the client and server. So first figure that will is for a COPE request or response communication to an machine or IoT device or mobile terminal. And the second figure, a computer or machine interface using IP communication to a mobile service provider for interchange with terminal. And the third figure, a machine or IoT device or mobile origin communication of COPE request or response communication. And the fourth one is an origin communication using SS7 and with a computer or machine interface using IP communication. Here this figure that is data expressible data interchanges between COPE MQ endpoints, COPE MQ clients, COPE MQ servers through COPE MQ broker and its services. COPE MQ service. So here it is for sending COPE messages of one endpoint to another. Queuing of messages by intermediate nodes and forwarding only when it suits, for example, when the message is sent, endpoint is awake or connected alive. COPE MQ endpoint functions implements the functions at the COPE MQ function set, serves as COPE MQ client and COPE MQ server. Register with RD server for using broker. So here RD server advertises a service and another function is receives advertisements from broker which may advertise a service and may permit implementation of a sleeping endpoints and a message queuing for receiving and awakening of endpoints. And we look at the broker functions of COPE MQ. So functions as a server node capable of storing messages to and from other nodes, perform a store and forward function between web clients and the COPE MQ capable endpoints, matches subscriptions and publications in order to route messages to right endpoint, sends a state of an endpoint when endpoint or a web client subscribes to the state of the endpoint, and enables the web client publishing of updates to the endpoint state through the COPE MQ broker, and returns the last published value to web clients or other endpoints on behalf of endpoints that are sleeping and acts as a proxy. So we have discussed in this session about data management and consolidation gateway functions, constrained environment for connected devices, and we discussed about COAP, constrained application protocols. SMSC here is SMS Service Center. This is mobile terminal. SMSSP, SMS Service Provider. HLR Home Location Register. MO is Mobile Origin. And these interfaces, web objects, these are publish, discover, subscription, RD and POP MQ broker. These are function sets. And this is the reference textbook I have used. Internet of Things, Architecture and Design Principle, written by Raj Kamal and published by McGraw-Hill Education. And the content is I obtained from the same textbook. Thank you.